All right, everybody. Hope you're doing well. In this video, we are going to tackle linear inequalities. Another one of these things that you should already be good at, but we're going to go over it anyway. Just remember two important things. I know it says 1 and 1 again. I'm sorry. My bullet point thing got all off. All right. Number one, if you multiply or divide both sides by a negative value, you must flip the inequality sign. Pretty easy rule. Like they literally teach it to you in like 5th grade. All right, number two, convert your final answer to interval notation. Now that we're getting better and better and better at interval notation, remember your final answer is going to be an inequality, but we want to turn it into an interval notation for the final answer. So please make sure you do that. All right, let's look at a couple really simple examples here. All right, so what do we do? Oh, see parentheses, distribute. 3x minus 3 plus 2 less than or equal to 5x plus 6. Let's see here. Combine like terms on the left. 3x minus 1 less than or equal to 5x plus 6. I'm going to subtract the 3x. Negative 1 less than or equal to 2x plus 6. Subtract the 6. Negative 7 less than or equal to 2x. Divide both sides by 2. And I get negative 7/2 less than or equal to x. Now, at some point, you can say, oh, there's a negative. I got to switch the sign. No. Slow down. Remember, if you divide by negative or multiply by negative, that's when you switch the sign. I didn't divide. The number I divided by was positive 2. Don't need to switch the sign. All right, so remember, you can flip this around and say, well, negative 7/2 less than or equal to x is x greater than or equal to negative 7/2. As long as the inequality is pointing at the same value, you can flip it around as long as it's still pointing at the negative 7/2. So now let's put this bad boy into interval notation. So we're going to do a negative 7/2. We want to be greater than negative 7/2. We're going to go towards infinity on the right. Interval notation, go left to right. Since we're allowed to equal negative 7/2, we're going to put a bracket there. Parentheses always go on infinities, and boom, voila, bing bong, there's your answer. Pretty easy, pretty nice, easy. All right, let's try another one out here. All right, be very, very, very careful. I can't say this enough. I know you guys are pre-calc honor students, but you got to be careful with these negative signs. They carry over. All right, here we go. 8 plus 3t minus 4 less than t. You know what? 5 minus 8. I'm going to do a negative 3 right now just because I'm smart. I can do two things at once. All right, on the left side, let's combine like terms. 8 minus 4 is 4, so we get 3t plus 4 less than t minus 3. Subtract the t over, 2t. Oh, you know what? Again, I can do two things at once. Subtract the 4 over, less than negative 7. Okay, I want to be going so fast and doing multiple things. If I didn't know, you guys should already know this. Divide both sides by 2. Crazy, we get another of these 7/2 again. Okay, sorry for that, put an equal sign. Less than negative 7/2. All right, once again, now we're talking about a value t being less than, so that would be all the way down towards negative infinity, up to negative 7/2, but we're going to put a parenthesis there because it doesn't say we're allowed to equal 7/2. So there is our nice interval notation final answer. All right, here's another problem where we see the dreaded fractions. All right. Remember, you can't cross multiply. First off, this isn't an equation anyway. Plus, we don't have one single fraction on each side. So the first thing I'm going to go ahead and do is I'm going to get one fraction on the left-hand side. So my common denominator is going to be 6. I got to multiply this by 2. Multiply top by 2. That'll get the 6. There's going to be my 2x. Got to multiply this by 3. Top by 3. That's going to be my plus 3. On the right-hand side, I'm going to get a 12 as my common denominator. So let's see here. I have times by 3 on the top and bottom. So get my common denominator there. So there's 3x times by 4 on the top and bottom. So there's my plus 4. All right, now a couple different things you could do to finish this problem off. But a lot of kids just want to jump and cross multiply. Be very careful here. If you cross multiply, you're like, okay, well, what goes on the left? What goes on the side that's the greater 2, right? Like, does the 6 times 3x plus 4 go over there? Or does the 12 times 2x plus 3 go over there? What side goes on the right where the arrow's pointing? You don't know, so don't do that. Got to be smart here. Slow down. Remember, another way you can compare fractions is if the denominators are equal, then that means the numerators have to be. So if I multiply the top and the bottom by 2 over here, Remember, if you do something to the bottom, you got to do the top. Then I get 4x plus 6 over 12 greater than 3x plus 4 over 12. So doing that got me a common denominator. So now I'm not trying to say eliminate the denominator, but the denominators are set. They're 12. I can't change that. So now I could think about the 4x plus 6 needs to be greater than the 3x plus 4. If that's true, then obviously the statement above it is going to be true, because when you divide by 12 on both sides, it's going to do the same thing to both sides. So that's why once the denominators are equal, then I could just focus on the top. So subtract the 3x to the left side, I get x. Subtract the 6 to the right side, and I get 4 minus 6 is negative 2. So that means x is greater than negative 2. So that's going to be, oh, I almost did a bracket. Sorry, parenthesis, negative 2, comma, infinity, because I want to be anything greater than negative 2. And there's your final answer. So just be a little bit careful. Don't jump the gun and start cross-multiplying when you're working with inequalities. All right, here's what we call a compound inequality. So we actually have this bounded here. So we got a negative 3 on the left, 5 on the right, and then inside is our algebraic expression, 2x plus 5 over 3. So when you're working with one of these compound inequalities, just make sure what you do to the left, you also do to the far right. So basically there's 3 parts. There's the left, the right, and the middle. You got to do the same thing to all parts. So if I'm going to get rid of the fraction, I'm going to multiply everything by 3. The left gets multiplied by 3. The right gets multiplied by 3, and when you multiply the inside by 3, the 3 cancels out, and you get 2x plus 5. All right, now I have to subtract 5, but I'm going to subtract 5 from the left, negative 14, subtract 5 from the right, 10, and when I subtract 5 on the inside, all I get is the 2x. Then I'm going to divide everything by 2. Divide the left by 2, divide the right by 2, divide the middle by 2, and you just get x. So now I'm now done. And I forgot my or equal to sign over here. So sorry. Now keep in mind here, did not happen in this problem, but in case again you would divide by a negative or multiply by a negative, all signs switch. All of them, right? Because you're doing it to all of the parts, left, middle, and right. So the signs would both switch. All right, so now interval notation, this is bounded. I'm bounded from negative 7 to 5. But I'm going to put a bracket on that 5 because I'm allowed to equal it. So there is my final answer. So easy. All right, hopefully it was a pretty easy video here on solving linear inequalities. And the only thing I'd say be careful with is, as always, fractions, and be careful with negatives. Those are where kids kind of get a little hung up. All right, guys, hope you enjoyed it. Hope it was really easy and you're ready to roll.